Hello viewers, today we are going to discuss an important topic in mathematics which is called the sets theory. Under this topic we are going to take the set definition, types of set, operation of set, properties of set, Venn diagram, which will be the last one we are going to use in wrapping it up. Then what is set? Set is part of discrete mathematics that has to do with the collection of objects with distinct character. Set is usually represented with a capital letter, while the elements inside are represented with small letter like A, B, C, D. Elements inside a set are enclosed with the open and a closed curly bracket like this. Set A is equals to A, B, C, D. Set B is equals to 1, 2, 3, 4. If you look at it very well, you discover that the elements inside are represented with small letter. That is the way we normally portray the element inside a set. Then types of set. We have the singleton set, we have the empty or null set. We have the final set, we have the infinite set, we have the equivalent set, we have the equal set, we have the unequal set, we have the disjoint set, we have the subset, we have the proper super subset, we have the proper subset, we have the overlapping set, we have the universal set. Element of set is represented like this. 2 is an element of B. The symbol in between 2 and B portrays is an element. Then the other one there, A is not an element of B. The symbol in between A and B portrays that A is not an element. So we have what is called the set declaration. This is the normal way we normally declare set. Set A is equals to X. Then X, which is the element of set A. These are what comprises of the set A. Set A is an integer less than 5. The first one is the set A. Then while the X there is talking about the element of the set A. Then if you move to the right, which is the right of the column, you discover that this is the definition of the set. Anything you have there is talking about the definition of the set. Sometimes it may appear like this. A is equals to X. Then we have the pipe sign. Immediately after the pipe sign, you have the definition of the element, which is something like this. It's almost the same thing with the first one, but the only difference here is that the first one is represented with colon, while this one is represented with the pipe sign. So that is the way we normally define set. Then what is singleton set? Singleton set is a type of set in which the element is 1. Anytime a set just have just one element, it is called a singleton set. So let's use an example to demonstrate it so that you can be able to understand it. Set A is equals to 2. Then set B is equals to C. If you look at set A and set B very well, what you see that it just comprises of just one element. So that is the reason why it is being called the singleton set. Then we have the empty set. This is a type of set that does not have any element. It is confusing. Sometimes some people might decide to just put something inside. It's confusing. We have the set A is equals to empty set. If you look at it very well, you discover that there is nothing inside the curly bracket. But if you don't want to represent it that way, you can also represent it this way by using B is equals to empty. That symbol portrays empty. So anytime you come across that symbol, it's trying to tell you that that set is empty. Then we have the final set. This is a type of set that has definite number of elements. Definite number of elements in the sense that you have a specific number of elements inside the set. Set A is equals to 2, 3, 5, 1. If you look at the element inside set A, there are 4, 2, 3, 5, 1. So anytime you can be able to count the number of elements inside a set, it is called a finite set. Then the opposite of the finite set is the infinite set. This is a type of set that does not have definite number of elements. So let's use an example to portray so that you understand it. From the set definition, set A is equals to S. X is any number greater than 7. This kind of expression is a little confusing, but what this expression is trying to tell you that any number greater than 7 is an element of A. Then if I ask ask you now to count all the numbers greater than 7, you keep on counting and you will never stop. So that is the reason why we call it infinite set, because the elements, they keep on moving along, they don't stop. That is the reason why we call it the infinite set. Then we have the equivalent set. Two sets are said to be equivalent. Look at the condition. Two sets are said to be equivalent if the number of elements in one is equal to the other. First of all, let's begin to understand the number of elements in a set. When we talk about the number of elements in a set, what we are trying to talk about is the cardinality. If you have a set that has just 4 elements, it means that the number of elements in that set is just 4. So the cardinality of that set is just 4. So let's use this example to portray it so that you understand it. It says, find the cardinality of set A and B. Set A is 1, 2, 4, 5, comprises of figure. Then why set B comprises of alphabet A, B, C, and D. So if we want to solve this kind of problem now, first thing we are going to do is to count the element inside. The element inside set A is just 1, 2, 4, 5. So if we count it, we have 4 figures, isn't it? Then we'll move to the other one, which is called the set B. So the element inside set B, they are just 4. So if we are going to calculate the cardinality of set A is equals to 4. That is, number of elements in set A is equal to 4. So when we talk about equivalent, we are saying the two sets must have the same number of elements. That is cardinality of a set. Cardinality of a set. Try to recall it. Cardinality of a set. So this is the way we normally represent the equivalent of a set. Set A is equivalent to B. The reason why set A is equivalent to B is because set A has the same number of elements with set B. So that is the reason why we call it set A is equivalent. So that symbol that have both side arrow is used to identify the equivalent of a particular set. The equal set. For you to understand the equal set, first of all, you need to understand equivalent of a set. If you don't understand what equivalent of a set is all about, you find it difficult. We just discussed the equivalent of a set by saying that the two sets must have the same number of elements inside. So that leads us to the equal set. We'll proceed a little further to define the equal set. Two sets are said to be equal when they have the same number of cardinality. That is the first one. Then the other condition there is the same element in both. They must have the same number of elements and they must have the same element in both. So if you look at it very well now, there is an example which we want to use to illustrate it. Set A is equals to 0, 1, 2, and 5. Then set B is equals to 5, 2, 1, 0. If you look at these two sets very well, first of all, let's try to check the first condition, which is the cardinality. 0, 1, 2, 5 is 4 elements. Then let's go to set B. 5, 2, 1, 0 is 4 elements. But if you look at the element very well, you discover they are the same, even though they are not arranged in the same order. The first one we have 0, 1, 2, 5. Then the second one we have 5, 2, 1, 0. If you look at it very well, you discover they are the same because they have the same number of cardinality and they have the same element inside. They are called equal set. That is the reason why I said for you to understand equal set, the first thing you need to understand is the equivalent of set. If you don't understand the equivalent of set, it will be difficult for you to understand what equal set is all about. So we have the unequal set, which is the opposite of equal set. Two sets are said to be unequal when the element of one set are not present in the other element. They may be equivalent to, but they are not equal. So let's use an example to demonstrate it. Set A is equals to 4, 1, 2, and 5. Then why set B is equals to 5, 2, 1, and 6. If you look at these two sets very well, you discover that they have a common thing. 1, 2. 1 and 2 is in both sets. But no, it's not just only 1 and 2. We have 1, 2, and 5. 1, 2, and 5 is in both sets. But 4 is in set A. 4 is not in set B. Then 6 is in set B. Then 6 is not in set A. So that is the reason why they are called unequal set. So the symbol of unequal set is this. So in between A and B, there is something you see there. There's a strike through on top of the equal to sign. The next set which we are going to discuss is called the disjoint set. Two sets are considered disjoint when they do not have a common element. Let's use example to demonstrate it. Set A is equals to 7, 8, 9, 2. Then set B is equals to 3, 4, 6. If you look at the two sets very well, you discover that there is no common element between the two because they do not have anything common, so they are classified as disjoint. So we represent it mathematically as A interset B is equals to empty set. So we'll move along to the next one, which is the subset. This subset which we are going to discuss is classified as the general subset. Please try to pay attention to it because it's very important. It will guide us in our next type of set which we are going to discuss. A set is considered a subset of another set if all its elements are present in the other set. Let's use this example to explain it so that you can be able to understand it more better. Set A is equals to 1, 2, 3, 4, 8, 9, 2. Then while set B is 3, 4, 1. If you look at it very well now, between these two sets now, set B elements are found in set A. 3, 4, 1. Check it very well. You discover that there is 3, 4, 1 inside. Because the element of set B are found in set A, so set B is called the subset of set A. So mathematically it's represented like this. This is the symbol we normally use to represent subset. So B is the subset of set A. So that is the way we normally represent it. So we are going to discuss the proper superset. The set A is the proper subset of set B. Then all the elements of set B are in A, but set A must contain at least one element which is not present in set B. What is this trying to explain? Let me just use this example to just clarify so that we can be able to understand it. If you look at these two sets now, we have set A which is 7, 8, 9, 2, 10, then 4. Then set B, we have 7, 8, 9. The element of set B, they are found is in set A. But one thing about it is that there are some elements of set A which is not found in set B because those elements are not found in set B. So set A is classified as the super subset of set B. So this is the way we normally represent super subset mathematically. A is the super subset of B. The first one you saw there, which is A is not equal to B, is trying to tell you that A is not equivalent to B. That is to say, it must not be the same. There are some elements in A which must not be found in B. That is the essence of that not equal to. Then the next one is the proper subset. The set B is the proper subset of set A. Then all the elements of set A are in of set B and A, but set A must contain at least one element which is not present in set B. Just like what I explained before, I said there are some elements in set A which are not found in set B. That makes set A to be called the super subset. So in this case now, set B, what is it called? So the set B is called the proper subset. So that is what this is all about. So if you look at it, let's try to use it. Let's use this one to demonstrate it. Look at it. It's the same explanation. Everything is the same. But the name we decided to call B in this case now, we'll call B as the proper subset of set A. Let's go to the next one, which is the overlapping set. The overlapping set is the opposite of disjoint set. Why I said is the opposite of disjoint set is because when we talk about disjoint set, when two sets does not have anything in common, they are classified as disjoint. But overlapping set, when two sets have something in common, they are classified as overlapping set. So mathematically we represent it by using the interset. A intersect B. If it is overlapping set, it means that there must be an element. But if it is disjoint set, it means it is going to be an empty element. So in this case now, A intersect B is equals to 3 and 4. So look at the two sets very well. We have 3 in set A, well, we have 3 in set B, then we have 4 in set A, then we have 4 in set B. So the two sets, they are called overlapping set because they have two things in common. So the next one which we are going to discuss is called the universal set. A set is considered as a universal set if it contains all the elements of other given set. It is represented by U or this symbol. There are some mathematical questions you will come across that will ask you to find the universal set from the given set. So the universal set is the combination of all the sets. But this example, universal set is already given. So let's look at the universal set now. 1, 2, 3 to 10. Then the other subset which are there. Like what we discussed, the subset, it means those sets that are inside another set. So in this case, now set A, set B, set C, they are subset of the universal sets. So let's discuss the set operation. Set operation are mathematical operation carried on two or more sets in order to obtain another set. This is where the mathematical aspect of set is going to take place. So please try to pay attention. The first one which we are going to discuss under the set operation is the union of set, set intersection, complement of set, set difference. Sometimes it is called relative complement. Then we have the Cartesian product, or sometimes we call it cross product. Then the last one which we are going to discuss under the set operation is called the power set. Operation of set, we are going to start with the first one which is called the union of set. Union of set refers to the combination of two or more sets without repetition. It is represented by small letter u. We use example to explain it so that you can be able to understand it, because this one has to do with the mathematical operation. So everything we are going to do from here now, we'll talk a little bit about the theory, then we'll discuss more about the calculation aspects. So the first example we have here is said find A union B from the given set. Then set A comprises of S, Y, Z, arrow, V, W. Then set B is Y, arrow, X. Then O, P, Q, just like that. Then if we want to find the union of these two sets, now we already know that set A comprises of S, Y, Z. Then set B comprises of Y, arrow, X. So if we want to combine it, the first thing we are going to do, because when we talk about union of a set refers to the combination of two sets without repetition. That is taking the element in a particular set and taking the element of another set without repetition. If they have something in common, you just have to take one. If they repeat the set like twice or thrice, you just have to pick one. So this is what we are going to do now. The A union B, the first one we are going to start with is the A. So set A, we are going to write everything pertaining to the set A. Set A comprises of S, Y, Z, arrow, V, W. So we'll put it this way. So after moving from the set A, we'll move to the set B. Then as we are moving to the set B, now you pay close attention so that anything that has already been written before will not repeat itself. So let's move along. Y, arrow, X is already there. So there's no need to put it. But O is not there, P is not there, Q is not there. So we'll put it O, P, Q. So that is the way to calculate the union of a set. We'll use another example again to still explain it so that you understand it. The second example is say find C union D. So from the given set C is equals to 1, 2, 3. Then Y set D is equals to 8 and 9. So if you want to combine these two things now, what you just have to do, you just bring the symbol set C union D. Then you bring out the first set, which is the set C. Set C comprises of 1, 2, 3. Then Y set D comprises of 8 and 9. If you look at the two sets, there is no repetition, so you just have to combine the two. So that is the way we normally combine union of set. So the next thing which we are going to discuss is the intersection of set. Intersection of set, we have already discussed this in our type of set when we are discussing disjoint set and overlapping set. When we said if two sets have something in common, they are called overlapping set. Then if two sets does not have anything in common, they are called disjoint set. So the mathematical representation which we are going to discuss, which is the set operation. So intersection of set occur when two or more sets have a common element or element in their set. It is represented with the inverted U like this. So we use this example to also explain it better so that you understand it. Find A intercept B from the given set. So set A is equals to 1, 3, 10, 21, 5, 8. Then Y set B is 1, 10, 7, 8. If you want to solve this kind of question, what you have to do is to pay a close attention to check the two sets if they have something in common, if they have an element in common. If they have an element in common, it means that there is an intersection. But if they don't have an element in common, it means that there is no intersection. So let's pay close attention to this problem very well. If you look at these two sets now, there is one in set A and there is one in set B. So which means there is one element. Then look at it again. There is 10 in set A and there is 10 in set B. So we have two elements. So if we want to calculate this, we say A intercept B is equals to 1 and 10. So these are the two elements. So that is the way we calculate the intersection. So but we are still going to repeat another example so that you can be able to understand it very well, because this is where the mathematical aspect of set begins from. So please pay close attention to it. I'm not trying to rush it. I'm going to make it very easy for us to understand it. So the next example is say find C intercept D from the given set. Then set C is equals to 1, 2, 3. Then set D is equals to 3 and 9. So if you check very well, there is a common element there, which is 3. So C intercept D is equals to 3. So that is the way we calculate the intersection of set. The next one which we are going to discuss under the operation of set is the complement of set, which is very interesting. Complement of set refers to element present in the universal set but not present in a particular set. It is usually represented with superscript C or I. So let's use example to explain it further so that you can also understand. Find a complement from the given set. So the first set which is given is the universal set. This is the symbol to indicate the universal set. So universal set comprises of 1, 2, 3, 4, 5, 6, 7. Then white set A is 1, 2, and 3. And what they said we should find is the complement of set A. So when we talk about complement, it means that those elements that are not present in a particular set, but they are present in the universal set, we are asked to find the complement of set A. And set A comprises of 1, 2, and 3. If you look very well, you discover that there are some elements in the universal set which are not present in set A. So those elements are called the complement of set A. So let's do it together. So if you look at it, those elements that are present in the universal set which are not present in the set A is 4, 5, 6, and 7. So that is the way we normally find the complement of a set. Then we'll move to the next one, which is called the difference of set. This difference of set, we normally call it as relative complement. Relative complement in the sense that it does not concern the universal set. It affects two sets that are not universal set. So the difference of two sets, e.g. C minus D, that is the way we indicate difference of set, is the set of all elements of set C that are not in D. What is this one trying to explain? Is that C minus D is trying to tell you that everything that is inside set C that are not in set D, that is the difference of the set. So we use another example also to explain it so that you understand it. So the first example we have here is A minus B from the given set, automatically that A minus B is trying to tell you that to find the difference of the two sets. That is to say that the elements that are present in set A which are not present in B, that is the complement, that is the difference of the set which we are going to look for. So let's find it. So A minus B is equals to, so the elements that are present in set A which are not present in set B, let's look at it very well. One is present in set A but it's not in B. Look at it very well. It said 10 is present in set A but it's not in B. Then 15 is present in set A but it's not in B. Then 8 is present in set A which is also not in B. So these are the elements. So A minus B is equals to 1, 10, 15, 8. The next set of operation which we are going to discuss is called the Cartesian product. What is Cartesian product all about? Cartesian product of two sets A and B is defined as the set of all other paired x, y such that x belongs to set A and y belongs to set B. Example, find the Cartesian product of set A and B, which states that S cross B. What is Cartesian product all about? Cartesian product is all about arrangement of two sets. If you want to arrange the element of two sets, that is what Cartesian product is all about. Taking an element from a particular set and combining it with an element from another set. That is what Cartesian product is all about. So we use this example to explain it so that you understand it. So let's look at it. A cross B. This is the way we normally read Cartesian product. A cross B. So this is the solution. If you look at it very well, let me try to explain it so that you understand it. A cross B is equals to, then you take the element from set A, which is 4. Then you try to combine it with all the elements of set B. That is, you are trying to do multiplication, which is product. That is why it is being called the Cartesian product. You take a single element from set A, then you combine it with all the elements of set B. Then once you are through, you move to the next one, which is the second one, which is the 5, which is the element of set A. 5 is the element of set A. Then you combine it also with all the elements of set B. Then once you are through, that gives us the Cartesian product. So let's look at it. We take the first element, which is 4, combining it with the element of set B, which is 7. So 4 and 7, 4 and 8, then 4 and 9. These are the elements of set B. Then you move along again to the other element of set A, which is 5. Then 5 and 7, 5 and 8, 5 and 9. So this is the way we normally look for the Cartesian product of two sets. Then the next one which we are going to discuss under the set operation is called the power of a set. Power of a set is the set of all subsets of a particular set, including the set itself and the empty or null set. Power set is denoted like this: P of A, whereby A is the set in question. First of all, let me try to explain what power of a set is all about. Power of a set is like permutation, whereby you try to arrange something. But in this case now, power of a set is only applicable to a single set. The set itself, you are trying to arrange the element of that set itself. We use example to illustrate it so that it will be easy. The first example we have here is a find the power set of the following set. In order to find the power of a set, the first thing we are going to do is to look for the cardinality of the power of a set, because the cardinality enables us to know the total number of elements inside a particular set. We have two sets here, set A and set B. We use the set A to illustrate the cardinality of the power of a set. Then also we also use the set B to illustrate the cardinality of the power of a set, and also find the power of a set from set B. So from this illustration, we use the set A to do the explanation. This is the formula we use to calculate the power of a set. Cardinality power of a set is equals to 2 raised to the power of n, whereby n refers to the total number of elements present in the given set. This is the set which we are going to look for the cardinality, which is set A, and p refers to the power set. So let's move along so that we'll be able to understand this. So we are trying to use the set A to do the illustration of the cardinality of the set. So we say P of A is equals to 2 raised to the power of 3. That 3 that is there is indicating the number of elements in set A. Set A has 3 elements. So 2 raised to the power of 3 is going to give us 8. So the cardinality of set A is equals to 8. Assuming we want to find the power of a set A, it means that the element inside set A is going to be equal to 8. But we are not going to find it. We are just using it to do illustration for you to understand the cardinality of set A. But we are going to use B to do the calculation. So let's move along. So the B aspect of it is set B is equals to 7, 1, 6, 5. So first of all, before we are going to calculate the power of a set, in this particular set, we have to know the cardinality of the set. So set B has 4 elements. So 2 raised to the power of 4 is going to give us 16. So by the time we try to do the calculation of the power of a set, which is the arrangement of the element inside set B, is going to give us 16 elements. This is the final arrangement. Let me explain it so that you understand it. We have set B is equals to 7, 1, 6, 5. Look at the left side of the screen. You will see set B is equals to 7, 1, 6, 5. So in trying to arrange the power of a set, we start with the empty set. Then we'll move to the first element of the set B, which is 7. Then you move to the next one, which is 1, then 6, then 5. Then by the time you are able to pick all the elements of all the sets, then you combine it together. So we are going to combine it in 2. So 7 and 1 will go together, 7 and 6 will go together, 7 and 5 will go together. Then you move to the next one, 1 and 6 will go together, 1 and 5 will go together, 6 and 5 will go together. Then after you are through with the 2, then you combine it in 3. So 7, 1, 6, 7, 1, 5, 1, 6, 5, 7, 6, 5. Then once you are through with the combination of 3, then you move to the combination of 4, because we have 4 elements already inside. So 7, 1, 6, 5. One thing you should take notice of, that there is no repetition in this place. If there is a particular element that is already there, you don't need to repeat it. So that is the way we normally calculate the power of a set. Properties of set operation. We are going to discuss the properties of set operation. When 2 or more sets are combined in order to form another set, operation is carried out. Properties of set refers to the properties that affect the operation of a set. Below are the basic properties. We just discussed the operation of set. There are some properties that have been attached to a set that you can be able to use to do some calculation, and these are what we are going to concentrate on. The first property here we have is called a commutative property. What the commutative properties is all about, it tells you that A union B is equals to B union A. So if you are asked to find A union B, and the same time they say you should look for B union A, automatically the answer is going to be the same. That is what the commutative properties is all about. Then we have the intercept. A intercept B is equals to B intercept A. Then we'll move to the associative property. The associative property is all about union. A union open bracket B union C, then close bracket, is equals to A union B close bracket union C. That is to say that once you combine B union C then union A, then it's still going to give you the same thing once you combine A union B then all together with union C. Then if you look for the intercept, which is A intercept open bracket B intercept C close bracket, is still the same thing as you looking for A intercept B then close bracket intercept C. Is going to give you the same thing. So this property is called the associative property. Yeah, the distributive property has to do with the combination of the intercept and the union. The first one we have here, it says B union C intercept A is equal to A intercept B union A intercept C. Then the B aspect of it is said B intercept C union A is equals to A union B intercept A union C. The identity properties. These properties has to do with the combination of a particular set with another set to produce that the same set. So if you look at the first one here, we have A union the empty set is equals to the set itself, which is the A. Then A interset universal set is equals to A. Then the complement property. The complement property has to do with the set of a particular element. Combining it with its own complement is going to give you the union. So in this case now, if you try to combine the set of A with its complement, it's still going to give you the universal set. Then if you look for the interset of set A and its complement, is going to give you an empty set. That is what the complement property is all about. So we are going to discuss some additional laws or property of identity. We have the idempotent law, which says A union A is still going to give you A. If you try to combine A with itself, it's still the same thing. The A interset A is still going to give you A. So we have the domination law. The domination law is almost the same thing with the idempotent law, but in this case is making use of the union and the empty set. The first one we have in this place is A union universal set is equals to A. Then A interset empty set is equals to A. Then we have the absorption law, which says that A interset B union A is still going to give you A. Then A union B interset A is still going to give you the set A. We're going to discuss another additional laws of complement. So the first one which we are going to discuss under this complement is called the Morgan's law. The Morgan's law has to do with complement. So if you try to look for A union B or in complement, it's still going to give you the complement of A intersects the complement of B. So if you look for A intersect B or in complement, it's still the same thing as A complement union B complement. Then we have what is called the double complement or involution law. What this is all about, if you try to look for the complement of a particular set twice, it's still going to produce that original set. So if you look for the complement of A twice, it's still going to give us the original set of A, which is the same thing as you trying to repeat it. At this moment, we are going to discuss Venn diagram. Please try to pay attention because this aspect is very important. This is where a lot of questions do troop in when it comes to set theory. What is Venn diagram? Venn diagram is a pictorial representation of the relationship between sets. If you look at the first diagram that is here now, if you look at the shaded portion, the shaded portion is telling us the relationship between A and B. So what is this shaded portion is all about? It's called A intersect B. So by the time you have two sets like this shaded portion, which is the middle, sharing relationship between the A and B, is called the A intersect B. Then we have another one which is displayed on the screen. If you look at the shaded portion, it combines the set of A and the set of B. So this one is called A union B. Then we have the third one here. If you look at the shaded portion of this third one, at the middle is white, while the other side is colored blue. So if you look very well, this kind of set is called A intersect B complement, which means that the set are not inside the interset. Then we have the fourth one here. This fourth one, if you look very well also, you will discover that the shaded portion is outside A and B. So this one is called A union B complement, which means the number or the element is outside A union B. Then we have this one which is called the set of A complement. If you look at it, A is not shaded, but outside A is shaded. That is to tell you that the element is not in A, but outside A, which is a universal set. So it is called a complement of A. Then we have the sixth one here, which is the set of A and B. If you pay a close attention to this particular one, you discover that there is no connection between these two. There is no linking. So this kind of set that does not have any connection between the two sets, we say the interset is empty set, or you can call this kind of set disjoint set. So you try to represent it mathematically. We use it this way: A interset B is equals to the empty set. So we use this symbol to indicate the empty set. The seventh one we have here is called A minus B, which is the difference set, which we discuss about when we are talking about the set operation. So in this case, what this means is that it's trying to tell you that all the elements of set A which are not in B, that is what A minus B indicates. Then we have the other one, which is called A is a subset of B, which means every element of A is inside set B. Then we have the last one, which is called set A. That is to say that the shaded portion is the set A. Then we have some formula we normally use. These are the formula we use to solve two sets. Please try to pay attention to this, because we are going to use it to solve some problems as we move along. The first one we have here is talking about the union of A and B. So it is represented like this: the number of set A union B is equal to the number of set A plus the number of set B minus the number of set A interset B. Then the second formula is almost the same thing with the first one, but there is a little difference here, which I'm going to explain. So it said the number of set A union B is equal to the number of A minus B. What this means is trying to tell you that the number of elements inside set A only, that is what A minus B is all about, then plus the number of set B minus A, that is to say the number of elements present in B only that are not found in set A. Then let's move along, plus the number of set A interset B. That is what the other formula is all about. But the difference between the two is that if you are given a particular question to solve and they instruct you based on the question that a particular set has a particular number only, that is to say that this particular number belongs to this set only, that is when you make use of this second one. But if the question doesn't specify, you just say the set of a particular number is 40 without specifying it only, you know that the first formula is applicable. Then let's see the third formula. The third formula is called the universal set. So the number of universal set is equals to the number of A union B plus the number of A union B complement. So there are some elements that are not found in A union B, but they will be outside A union B, so those ones are called the complement. So you combine it with the union of A and B, it will give you the universal set. So these are the three formulas we are going to use in calculating the questions we are going to come across in this particular tutorial. So these are the two sets. So let me try to explain it here so that you understand it. A union B is equal to the number of set A union B, then the number of A, which is talking about the number of set A, then number of set B is equal to the number of elements of set B. So you just pay attention. This is the interpretation of everything concerning the formula, which I just discussed earlier before. Without wasting much time, we are going to use two examples to do the explanation of the formula, which we just illustrated not quite long. So the first example we have on the screen is that in a class of 40 students, 24 play football, 18 played volleyball, and 6 do not play any game. How many students play both football and volleyball? Automatically, what the question is demanding for is the intersection of the football and the volleyball. So without wasting much time, we are going to move to the solution aspect. The first thing we are going to do is to list out the parameter from the question. The first one we have here is called the total number of students, which is called the universal set, is equals to 40. The question states in a class of 40 students. So the total number of students are 40 students. Then the number of students that participate in football is 24 students. Then why the number of students that participate in volleyball is 18 students. Then why the number of students that do not participate in either volleyball or football is 6 students, which is the question then. It states that 18 played volleyball and 6 do not play any game. That is to say that these 6 students do not participate in either the football or the volleyball. Then the question asks us to look for the intersection of the volleyball and the football. So let's begin to bring out the formula that connects the universal set and the union of the two activities, which is the volleyball and the football. So the formula states the universal set is equal to the number of students that participate volleyball and football plus the number of students that does not participate in any of these two activities. So let's begin to impute the parameter. The universal set is equal to 40, which was already given from the question. So why the number of students that does not participate in any of these two activities is 6. So let's impute the parameter. So 40 is equal to the union of the football and the volleyball plus the number of students that does not participate in any of these two activities. So by the time we begin to rearrange the equation is going to look like this, which is 40 minus 6, which is equal to 34. But the question asks us to look for the intersection of the football and the volleyball, not the union. But why are we calculating for the union? Yeah, we are calculating for the union is because there is a formula that connects the union and the intersection. That is the reason why we are calculating for the union, because by the time we know the union, automatically we can be able to look for the intersection. So let's bring the formula that connects the union and the intersection. So the formula that connects the union of volleyball and football is equal to the number of students that participate in football plus the number of students that participate in volleyball minus the intersection. So we have already know the number of students that participate in football and volleyball, which is equal to 34. So we impute the values into the equation. So it's going to be 34 is equals to 24. 24 represents the number of students that participate in football. Then why the 18 refer to the number of students that participate in volleyball minus the intersection. We didn't know the intersection. That is the reason why we decided to use notification to display it there. If we decide to rearrange the equation, it's going to look like this. 34 is equals to 42 minus the intersection. So if we are going to make the intersection the subject of the formula, is going to look like this, which is 42 minus 34, which is equals to 8. If we are going to represent this one using the Venn diagram, it's going to look like something like this. If you pay closer attention, we have something inside the football set, which is 24 minus 8. Why is it 24 minus 8? The question said 24 is the number of students that play football, but we are having 24 minus 8. The reason why we are having 24 minus 8 is talking about the number of students that play football only. Assuming the question demand that you should calculate the number of students that play football only. So it's going to be 24 minus 8. The 8 is representing the intersection. Then also do the same thing for the volleyball, which is going to be 18 minus 8. So that is the way we normally calculate if we are trying to calculate for football only or volleyball only. So with this, we'll move to the other aspect of the example, which we are going to use to do this. Another explanation of the formula. So flow with me. So in this aspect of it, the question that we have on the screen states that in an examination, 18 candidates pass mathematics, then 17 candidates pass physics, 11 candidates passed both subjects and 1 candidate failed both subjects. Then the first question is said, find the number of students that pass mathematics only, the number of students that pass physics only. Then why the third question is asking us to look for the total number of candidates that sat for the examination. So first thing we are going to do is to list out the parameter in the question. The first parameter that we are trying to bring out is not included in the question, but we are going to use question mark to represent it because it's not given. So the first one is talking about the total number of students that participate in the activities, which is the exam. So it's not given in the question, so we use question mark to represent it because it is not known from the question yet. Then the number of students that participate in mathematics is equals to 18. Then the number of students that participate in physics is equals to 17. Then the number of students that participate in mathematics and physics, that is to say the intersection of mathematics and physics, is equals to 11, which was stated in the question. The question states 11 candidates passed both subjects. That is to say, the both subjects is representing the maths and the physics. So let's move along. Then the next parameter which we are going to display is the number of students that do not participate in any of the subjects. So it's going to be mathematics union thesis, or in complement is equals to 1 candidate. Then the A aspect of the question is asking us to look for the number of candidates that pass mathematics and physics only. So there is a formula that we normally use, which is displayed on the screen. What the formula is all about is the number of candidates that pass mathematics minus the number of candidates that pass mathematics and physics, which is the intersection. So from the question we are made to understand that the number of candidates that pass mathematics is equals to 18. Then the intersection of mathematics and physics is equals to 11. So 18 minus 11 is going to give us 7. So the number of candidates that pass mathematics only is equals to 7 candidates. Let's go to the B aspect of the question. The B aspect of the question is asking us to look for the number of candidates that pass physics only. So there is a formula that we normally use, which is displayed on the screen, which means the number of candidates that pass physics minus the number of candidates that pass mathematics is equals to the number of candidates that pass physics minus the intersection of mathematics and physics. From the question we are made to understand that the number of candidates that pass physics is equals to 17. Then why the intersection of mathematics and physics, that is the number of students that pass mathematics and physics, is equals to 11. So 17 minus 11 is going to give us 6. So the number of candidates that pass physics only is equals to 6. Then the C aspect of the question is asking us to look for the universal set. At this particular stage, it is still unknown, so we use question mark to represent it. But there is a formula that connects the universal set and the two activities, which is the mathematics and physics. The formula represents that the union of mathematics and physics plus the union of mathematics and physics complement. The complement there is telling us that there is a candidate that does not pass physics or mathematics. From the question, we have already known the union of physics and mathematics. So the union of physics and mathematics is equals to 7 plus 6 plus 11. The 7 there is talking about the number of candidates that pass mathematics only. Then while the 6 is representing the number of candidates that pass physics only. Then plus 11. The 11 there is representing the number of candidates that pass physics and mathematics. Then plus 1 is equals to 24 plus 1. So the union is equals to 24. Then plus 1. So the universal set is equals to 25. So the total number of students that sat for the examination is equals to 25. So if we want to represent this using a Venn diagram, it's going to look like this. 18 minus 11, 17 minus 11. 18 minus 11, we are looking for the mathematics only. Then 17 minus 11, we are looking for the physics only. At the end of the calculation, it's going to look like this. At this particular session of the tutorial, we are going to discuss the three sets, how they are being represented using a Venn diagram. The last one which we discussed is called two set. So let's move to the three set Venn diagram representation. The first diagram we have on the screen is called A intersect B intersect C. Please pay attention to the shaded portion, because the shaded portion, that is what we are explaining. The shaded portion represents A intersect B intersect C. So if we want to represent it mathematically, it's going to look like this: A intersect B intersect C. Then while the second diagram on the screen, the shaded portion of the diagram represents A intersect C minus B. What this means, it means that the element belongs to the intersection of A and C, but they are not found in B. Then we have the third diagram. The shaded portion of the third diagram represents B intersect C minus A, which means the element belongs to the intersection of B and C, but they are not found in A. Then we have the fourth one, which is also the same thing as the intersection, but in this case now it represents A intersect B minus C. That is to say that the element belongs to A and B, but they are not found in C. Then we have the fifth one. Every part of each set is being shaded. So this one is called the union of the three sets, A union B union C. Then we have the sixth one. The shaded portion is just only applicable to C. So what these are represent, it means C minus A, open bracket, A union B, close bracket. What this means is, means that the element belongs to C only, but they are not found in A and B. It is just only applicable to just C. So let's move to the other aspect of it, which is the seventh diagram. The seventh diagram is telling us about the set of B only. The shaded portion represents the set of B only. So B minus open bracket A union C. That is to say that the element belongs to B only, but they are not found in A union C. Then we have the eighth one, which is this. This eighth one, the shaded portion is on A. So what this represents, it means that the elements are found in A only, but they are not found in B and C. So if you represent it mathematically, it's going to look like this: A minus open bracket B union C, close bracket. Then we have the ninth one, which is represented on the screen. If you look at it very well, please pay attention to it. The set of A, B, and C are not shaded, but outside A, B, and C are shaded. What this means, it means that A union B union C all in complement. It means that the elements are found outside this three set. That is what the complement is all about. So these are the 9 Venn diagrams which we are going to use to explain the three sets. As time goes on, we are going to use the example to do some illustration about it. But before then, let's move to the formula aspect of it. Just like the two sets, there is also a formula for the three set. In the two set Venn diagram, there was a formula we list that, and also in this three set Venn diagram, it also has a formula which we are going to display. So the first formula we have on the screen is called the union of the three set is equals to the number of elements of A plus the number of elements of B plus the number of elements of C minus the number of elements of A intersect B minus the number of elements of A intersect C, then minus the number of elements of B intersect C, then plus the intersection of the three sets. So this formula is used to look for the union of the three sets. Please write it down because we are going to use it to do calculation in the next aspect of this tutorial. So please do yourself a favor by putting it down. So let's move to the other aspect of the formula. This aspect of the formula is used to calculate the universal set. If we want to calculate the universal set of the three sets, is equals to the union of the three sets plus the union of the three sets all in complement. So this is the formula we use to calculate the universal set. But assuming, for example, you want to look for a particular set from the three sets only. Let's assume, for example, now we want to look for the set of A only, just like what we have on the Venn diagram. The Venn diagram of 8 on the screen. If you look at the diagram, the 8th number there, it represents A minus open bracket B union C close bracket. That is to say that the shaded portion of that 8th diagram is only on A. So if you want to calculate such kind of set whereby the element just belong to it only, you use this formula. But in this case now, what we are calculating for is just A only. So the number of elements of A minus B minus C close bracket is equals to the number of elements of A. Then you move to the aspect where they share connection, which is the intersection, minus A intersect B, then minus A intersect C, then plus the intersection of the three sets. So this formula is mainly used to calculate the number of elements in set A only. So if you want to use it to calculate for B, you just have to interchange the parameter. Anywhere you see A, you put B. So if you want to use it to calculate for C, you also do the same thing. We are going to use an example to see how the formula is being used. The question we have on the screen states, in a technical school of 149 students, 69 offer physics, 79 offer chemistry, and 80 offer biology. 20 offer both physics and chemistry, 25 offer both physics and biology, while 42 offer both chemistry and biology. Each student offer one of these subjects. The A aspect of the question is asking us to draw a Venn diagram to illustrate this information. Then while the B aspect is asking us to find the number of students that offer physics and biology but not chemistry. Then the C aspect is asking us to look for how many students offer either one of the three subjects. So without wasting much time, let's go to the solution aspect. The first thing which we are going to do in the solution aspect is to list out the parameter. The first parameter is called the total number of students in the technical school, which is equal to 149 students. Then while the number of students that offer physics is equal to 69. So which is displayed on the screen. Then the number of students that offer chemistry is 79. Then the number of students that offer biology is equal to 80 students. Then we have the intersection of physics and chemistry. That is the number of students that offer physics and chemistry is equal to 20. The number of students that offer physics and biology is equal to 25 students. The number of students that offer chemistry and biology is equal to 42 students. From the question, we are not given one parameter, which is the intersection of the three sets. So we are going to use question mark to represent it, which is like this. But let's use S to represent it. So it's going to look like this. So the intersection of the three sets is equal to S. The first aspect of the question is asking us to use a Venn diagram to illustrate the information, which is like this. So if you look at the screen, please pay attention to it. This is the Venn diagram. So the set of physics is equal to 69 minus 20 minus 25 plus X. That is to say the number of students that offer physics only. So you also do the same thing for the chemistry, the biology. Then why the X at the middle is representing the intersection of the three sets. And the B aspect of the question is asking us to look for the number of students that offer physics and biology. And we are made to understand that the universal set is being connected with the union of the three set plus the union of the three set complement, which is this. So from the question, we are made to understand that the union of the three set complement is equals to 0. Why is it 0? Because the question states that each student offer one of these subjects, which means that each of the students in the class offer at least one of the three subjects. That is to say, there is no student in that technical school that do not offer any of the three subjects. So if we decide to slot in the parameter into the equation that connects the union and the complement together, it's going to look like this. From the question, we are already made to understand that the total number of students in the technical college is equals to 149. So if we slot it, it's going to be 149 is equals to the union plus 0. So if we make the union the subject of the formula, is going to be equal to 149. But the question we are going to look for is for physics only. If we want to calculate for physics only, the formula that we normally use to calculate for physics only is going to look like this, which means the number of element of physics minus chemistry minus biology, all in bracket. That is the look for physics only, is equals to 69 minus 20 minus 25 plus s. Then if you pay closer attention to the Venn diagram on the left of the screen, you discover that it's the same thing. We have 69 minus 20 minus 25 plus x. But at this particular stage, x is unknown. X represents the intersection of the three sets, which we did. P intersect C, intersect B, which is physics, intersect chemistry, intersect biology is equals to x. So if we are going to look for s, we are going to calculate it using the union formula. So we'll slot it into the union of the three sets. This is how it's going to look like. The union of the three sets is a combination of all the elements in the three sets. So if we decided to slot in, this is how it's going to look like. The x we have then is representing the intersection of the three sets. Then you move 42 minus x, which is coming to the aspect of chemistry intersect biology. Then you move to the 25 minus x. 25 minus x comes from physics intersect biology. Then if you move to 20 minus s, it comes to the side of physics intersect chemistry. Then we have 80 minus 25 minus 42 plus s, which is the set of B only. Then we have 79 minus 20 minus 42 plus s, which is the set of chemistry only. Then we have the last one, which is 69 minus 20 minus 25 plus s, which is the set of physics only. So the union of the three sets is going to look like this. So if we decided to collect like terms, that is by rearranging the equation, it's going to look like x plus 141. So if we make s the subject of the formula, it's going to look like this: 149 minus 141, which is equal to 8. If you want to use another approach in looking for s, this is how it's going to look like. So the union of the three sets. So if we slot in the parameter from the question into the formula, it's going to look like this. 69 is representing the number of elements of physics, that is the number of students that offer physics. Then 79 is representing the number of students that offer chemistry. Then 80 is representing the number of students that offer biology. Then 25 is representing the number of students that offer physics and biology. Then Y20 is representing the number of students that offer physics and chemistry. Then 42 is representing the number of students that offer chemistry and biology. Then YS is representing the intersection of the three sets. So if we decided to collect like terms, this is how it's going to look like: 141 plus x. If we decide to make x the subject of the formula, it's going to be 149 minus 141, which is equals to 8. So any of the approach can suit you. Anyone that you know that is easy for you, you apply. But what we are asked to look for is the number of students that offer physics and biology and not chemistry. So if we are going to look for the number of students that offer physics only, this is the formula. It's equals to 69 minus 20 minus 25 plus S. If you go back to the Venn diagram, you discover that 69 minus 20 minus 25 plus S is inside the set of physics. So if we decide to collect like terms, it's going to look like this: 69 minus 20 minus 25 plus 8. The 8 there is representing the intersection of the three sets, because we already know the intersection of the three sets. So we decided to impute the 8 into the formula. It's going to be equal to 32. So the number of students that offer physics only is equals to 32. So let's move to the aspect of the biology only, because we are going to combine the two together. So if we want to look for biology only, it's going to look like this: is equals to 80 minus 25 minus 42 plus S. If you also move back a little step to the Venn diagram which we illustrated, you discover that 80 minus 25 minus 42 plus S is inside a set of biology. So if we decide to impute the parameter, we already know S to be 8. So if we impute it into the equation, it's going to give us 21. But what we are asked to look for is physics and biology. What this represents, it means a combination of the number of students that offer physics only plus the number of students that offer biology only. So if we decide to add the two, it's going to look like this: 32 plus 21 is equals to 53. Then why the C aspect of the question is asking us to look for how many students offer either one of the three subjects, which is equal to 149. At this particular junction, I want to appreciate you for viewing it, but if you fail to understand any aspect of this tutorial, please pause it and go back to that aspect so that you can be able to understand it very well. The essence of this tutorial is not for me to show that I know how to solve maths, but it's for you to understand it. Thanks for viewing. Please don't forget to subscribe to this channel Benurupe by clicking the subscribe button. Thank you. See you in the future.